Hi, this is Mrs. Sigala, and this is the key for homework 4.8, writing chemical formulas for acids. And again, I'm going to write some of the simple rules down at the bottom, okay, for acids, because remember we're dealing with two types of acids, and so we are dealing with, okay, the first one that we covered was a binary acid. Okay, and we know that binary is going to contain two elements. And we know that it's going to have the prefix hydro. Okay, it's going to have the root or stem of the second element. Okay, and okay, that second element is going to end with the suffix "ic." Okay, and right now we'll write some things that they all have in common. Okay, and also end with acid. Okay. All right, so then we also have binary acids. Let me get this a little closer. I'm going to get a different color so it's a little bit easier for us to tell the difference. We also have what's called ternary acids. Okay, these will include a polyatomic ion. And this is where we covered that little phrase, okay? I ate an icky white mouse. So if the polyatomic ion ends in ate, we were changing it to ick. If it ended in ite, and I'm running out of space here, we were changing it to OUS. But now today we're going to be reversing that, okay? Now, what these acids have in common with each other is they all begin with, we can identify them quickly because they all begin with hydrogen. Okay, and they all end with the word acid. All right, so let's go through our list here, and we're going to identify our acids very quickly. So again, here we have acid. We have number 3 is an acid. Okay, we have number 4, 6, 8, 9, 11, 12, 13, 15, 16, and 18. And we know that those are all acids, again, because they end with the word acid. That's the only thing I'm looking at right now. Now, next, I'm going to go back to my acids, and I'm going to separate between binary and ternary. And that way I can apply one rule at a time. So now I'm going to look for my binary, and all of my binary should have the prefix hydro, okay? And so I'm going to label it with the B for binary, okay? And I might forget one, but I'll find it eventually. So here's another binary. Hydro. Here's another binary. Careful not to confuse hypo with hydro, okay? Hypo is not the same thing as hydro. And it looks like that's it for binary. So automatically, we look at the rest. Okay, here we have dichromic acid, that's ternary. Nitrous is ternary. Sulfuric, ternary. Chloric is ternary. Phosphorus, ternary. Nitric, and ternary. Hypochlorous, chromic. Oh, and chromic acid's on there twice. Okay. All right. So, so let's look at our binary acids first. Okay. And again, they're all going to start with hydrogen. So I'm going to go ahead and put hydrogen on all of them. Okay. So here's my hydrogen. Okay. All right, so They all start with hydrogen. So I know that for sure. Now I'm going to focus only on binary or ternary. So I'm going to stick to binary first. So I know binary, again, it only has 2 elements. Nitric, this has to do with the root or stem for nitrogen. And again, I'm using the crisscross method for everything except for covalent compounds. So if I look at hydrogen, it's in group 1. And actually, when you get your periodic table of elements, the very first thing that you want to do, because you'll probably get a blank one for your test, the very first thing that you want to do is go through your periodic table, and write down those oxidation charges. So group 1 is +1, group 2 is +2, group 3 is +3, group 4 plus or minus 4, or it can also be +2. Then we go back in reverse, -3, -2, -1, and 0. Okay? All right. So I identified my oxidation numbers because I'm going to need them. Okay? And so I know hydrogen, since it's in group 1, it's going to have an oxidation charge of +1. Nitrogen is in group 15, so it has an oxidation number of -3. I'm going to be crisscrossing. So this 3 is going to come over in front of the H. This 1 is going to go behind my nitrogen. So my formula now becomes H3N. Okay? And that's it. That's all it is. So I'm going to find my next binary acid. Okay, here we go with hydrobromic acid. And I know that the root part of that is bromine. So bromine, okay, where is bromine? Again, bromine's over here. Okay, and so I'm going to write that down. So it's HBr. Again, hydrogen will always be +1, and hopefully I give myself enough room. And bromine's in group 17, which means it has an oxidation number of -1. Again, I'm going to be crossing those oxidation charges. When I cross them, okay, this 1 is going to go in front of the hydrogen, the 1 in front of the bromine. So my formula is going to be H1Br1. Now remember, whenever we have just 1 of each, we don't need to write those. So my formula can just be HBr. Okay? Alright, my last binary acid, I have hydroselenic acid. And again, my root word for that is Se for selenium. Hydrogen is +1, and I keep forgetting to leave myself a little bit of room. Selenium is in group, it's right over here. It's in group 16, so it has an oxidation charge of -2. So again, I'm going to include it on here, -2. I'm going to crisscross. This 2 is going to go in front of the hydrogen. This 1 in front of the selenium, so my formula should be H2Se. I do not need to write that 1 after the Se, because again, there's only 1, so it's assumed that there's 1. Alright, so on here, I went ahead and included the polyatomic ions, the 20 common, and I used this one because it fit better, but again, you'll have access to the one behind your periodic table of elements, okay? And so let's look at our acids. Basically, with ternary acids, we know that little term I8 in icky white mouse, and that means that 8 will convert to ick, and ite will convert to OUS, or OS. Now, in this case, we're working in reverse. And so now we're looking at the suffix, and if it ends with ick, then we're going to revert back to 8. If it ends with OUS, we're going to go back to ite. Okay? All right, so let's look at the first one. And the first one ends with ick. So that means that this polyatomic ion should be dichromate. And if I look for dichromate on my list, here's dichromate. Okay. And here's my formula, Cr2O7. So I'm going to go ahead and write that down. Cr2O7. And I always like to write parentheses when I'm working with polyatomic ions. Now, according to this polyatomic ion, it has a charge of -2. And again, hydrogen has a charge of +1. So again, I'm going to include parentheses with my polyatomic ion, just to be on the safe side, because this 2 is going to come all the way over here, and this 1 is going to go outside my parentheses behind it. So my formula should be H2Cr2O7. I'm writing too big. All right, so next one we have nitrous acid, and then an OUS. So this is reverting back to ite. So this one is talking about nitrite. So again, I'm going to look for nitrite on my list. Here's nitrite, and here's my symbol, my formula. My oxidation charge, again, is a -1. Okay, so I'm going to write that down. I'm going to give myself a little bit of space because, oops, I have NO2. Again, -1. Hydrogen is +1. These crisscross. So my formula is actually, it doesn't have to change. And in this case, we don't need parentheses because there's only one polyatomic ion and there's only one hydrogen. All right, sulfuric acid, again, it ends with IC, which means that our polyatomic ion will have ended in 8. So it's not sulfite, it's going to be sulfate. Remember here, SO4. And this one has a charge of -2. All right, so -2. So that's SO4. I'm going to, again, parentheses. Okay, charge is -2. Hydrogen is always +1. I'm going to crisscross. And again, my formula is H2SO4. Okay. Next we have chloric acid, and again, ic means we're going back to chlorate. Look at my table. Chlorate is right over here. ClO3, and it has a negative charge 1. Hydrogen is +1. I'm going to crisscross those charges. So my formula is HClO3. And again, I don't need parentheses but because there's only one of those polyatomic ions. All right, phosphorus, OUS. That means it's not phosphate, it's going to be phosphite. Okay? Because again, OUS is going to go to ITE. So I'm going to look for phosphite on my list. Here's phosphite, PO3 with the charge of -3. Okay, hydrogen is +1. Okay, my 3 crosses over in front of my hydrogen, my 1 behind my phosphite. My formula will be H3PO3. Okay. All right, next I have nitric acid, and again it ended in nitric, so I'm going to revert back to 8. So in this case, I'm looking at nitrate. And when I look at nitrate, I have NO3 with the charge of -1. I'm going to go write that down. Okay, my hydrogen is +1. I crisscross those. And my formula is HNO3. I have hypochlorous, OUS. I'm going to revert back to ite. So here we look for hypochlorite. Here's hypochlorite, ClO with a charge of -1. And I always put my charge, outside my parentheses. Hydrogen is +1. Again, I'm going to crisscross those. So my formula is simply HClO. Right? Chromic acid, again, it ends with ic. So I'm going to revert back to 8. Here's chromate, Cr4, with a charge of -2. So I'm going to put that down. CrO4. Oops. With the charge of -2. Let me make sure I got this one right. Yes, okay. All right, and then again, I'm going to take these oxidation numbers and I'm going to crisscross. Oops, I forgot to write +1 over here. So my formula is H2 CrO4. And I don't need a parentheses because, again, I only have one of these polyatomic ions. And again, 18, it's the same thing in this case because we doubled up on that question. So I'm just going to write down the formula, H2CrO4. All right, so now let's go back to what we covered earlier. And so we covered covalent compounds yesterday. And so here we identify tri, so we know that that's covalent. Again, tricovalent, tricovalent. We have we weren't very creative with these because they all appear to be tri except for one, which uses pentoxide, but still it's covalent because of that prefix. So again, we have to make sure that all of our covalent compounds are nonmetals, okay? And so again, I'm going to be looking to the right of my zigzag line rather than looking throughout my entire periodic table. So I'm going to be sticking to this area over here. And again, remember, this is the only time when we do not use these oxidation numbers because we're given the subscript or the number of these atoms based on the prefix. So you have xenon triiodide, xenon, iodine, and tri means 3. And I went ahead and included these prefixes for you right over here in case you don't remember. Okay. So next we have nitrogen triiodide. We have nitrogen and 3 iodines. We have sulfur trihydride. So we have sulfur. Hydride is hydrogen. We have 3 of those. Next we have phosphorus trinitride. So we have phosphorus, nitrogen. We have 3 of those. Phosphorus tribromide, P and Br, and we have 3 bromines. We have phosphorus pentoxide, we have P, O, and pent means 5. Right, and that's pretty much about it for your homework.